In this video I will show you an extensive introduction on data visualization using the ggplot2 package in the R programming language. In a first section in this video I will explain the grammar of graphics that is used by the ggplot2 package. Then I will use a very simple dataset to demonstrate how to apply the grammar of graphics using the ggplot2 package in practice. And then in the third section, I will use a more complex data set and I will analyze and visualize this data set using ggplot2. So without too much talk, let's dive into the R code. So before we jump into the R code, I want to talk very briefly about the grammar of graphics which is used by the ggplot2 package, because if you understand these principles, it's very simple to use ggplot2. And the grammar of graphics basically says that a plot is separated into different layers, and you can add these layers on top of each other to change a plot. So in case of ggplot2, you usually specify a data set that you want to use. Then you specify aesthetics, which specifies stuff like color, size and shape of your plot. Then you specify geometries, which tell ggplot2 if you want to draw a scatter plot, a bar plot or a histogram. And then you have other layers that you can add on top, which specify the design of your graphic. The text that you can see here is published on the Statistics Globe website. I will put a link into the description of this video so you can read about the grammar of graphics in more detail on the website. However, it's very important to keep in mind that ggplot2 uses this layered approach and that you can stack different layers on top of each other in your graphics. So as explained, the ggplot2 package uses the grammar of graphics to create data visualizations. In the next section, I will demonstrate how to apply this grammar of graphics using the ggplot2 package to visualize a very simplified dataset. As a first step, before we can draw a ggplot2 plot, we need to create some example data, as you can see in lines 2 to 6 of the code. So after running these lines of code, a new data frame called data is appearing at the top right, and we can print this data frame to the bottom in the RStudio console by running line 7. And then you can see that our example data frame contains 9 rows and the 3 columns X, Y and group. And the columns X and Y contain numeric values, and the group column is a group indicator which splits our data frame into 3 groups A, B and C. Now if we want to draw our data in a ggplot2 plot, we also need to install and load the ggplot2 package, as you can see in lines 9 and 10 of the code. I have installed the package already, so for that reason I'm just going to load it with line 10. And after running this line of code, we can use the functions of the ggplot2 package. And typically, if you would like to create a ggplot2 plot, you would start by specifying the ggplot function. And then within the ggplot function, you would usually specify your data frame. In this case, our data frame is called data. And then you would specify the aesthetics of your plot. And in this case, we want to draw the columns X and Y. And then on top of this, you add the first layer to your plot using the plus operator. So remember the previous section where I spoke about the different layers that you can add on top of a plot. So in this case, we are adding a geometry, which is the geometry geom point. So after running these lines of code, you can see at the bottom right of RStudio that a new scatter plot is created. So we created a scatter plot because we used the geometry geom point. And for that reason, you can see that our data was drawn in a scatter plot, whereby our X column is shown on the X-axis and the Y column is represented by the Y-axis. Now, as you have seen, it is very simple to create a ggplot2 plot by simply specifying our data, our aesthetics and a geometry. However, now we can modify this plot in many different ways. And the first way I want to show you is that we simply can change the arguments within our geom point function. So in this case, let's assume that we want to increase the size of our points. And in this case, we have to specify the size argument, and the larger the value we set here, the larger our points will be. So after running these lines of code, you can see that our plot is updated and now the point size was increased. It's also possible to specify colors in our ggplot2 plot, and we can do that by specifying the col argument. Col stands for colors. And in this case, we specify this argument within the aesthetics of our ggplot2 plot, and we set this argument to be equal to our group indicator. So after running these lines of code, you can see that our plot is updated once again. And as you can see now, the points in our scatter plot are shown in 3 different colors, and each of these colors corresponds to one of the groups in our data. And you can also see that the ggplot2 package has automatically added a legend on the right side of the plot, which shows that the color red belongs to the group A, the color green belongs to the group B, and the color blue belongs to the group C. We will now use these specifications of our plot as a basis. And if we want to use such a basis repeatedly, it makes sense to store the output of the ggplot function in a data object. And we can simply do that by using an assignment arrow. And all this code is exactly the same as in the previous lines of code. However, this time I'm storing the output in a data object that I call ggp simple. So after running lines 28 to 32 of the code, this plot object ggp simple is appearing at the top right. And if we would call this plot object, our plot would be drawn once again. However, now we can also use this plot object to add additional layers to our plot. So once again, remember the grammar of graphics that I have explained in the first section. Now one thing we could do is that we add a scale layer. And in this case, I want to change the axis limits on the x-axis. And for that reason, I use the scaleXContinuous function. Within this function, I specify the limits that I want to use. So in this case, I want to use a range from -3 to +15. And now I can simply use the plus operator to add this layer to our plot object that we have created before. So if you run these 2 lines of code, you can see that our previous plot is shown once again, but this time with a different x-axis range. So in this plot I have shown how to use a scale layer to change the x-axis range. However, you have different types of scale layers. So for example, you can also use a scale layer to change the colors of your plot. So in the next example, in lines 37 to 39 of the code, I'm using the scale color manual function. Within this function, I specify the breaks argument to tell ggplot2 that I have the 3 groups A, B, and C, and that I want to change the colors of these groups. And I specify the values argument, and I set this argument to be equal to the 3 hex color codes that I want to use to color our plot. And as in the previous example, I can use our ggp simple plot object that I have created before, and the plus operator to add our additional layer. So if you run lines 37 to 39 of the code, you can see at the bottom right that our plot is updated once again. Our x-axis is as in the beginning of the tutorial, so this x-axis represents the default specifications. However, this time you can see that we have changed the colors of all the points in our plot. Now it's also possible to add multiple scale layers to a plot, and this is what I want to show you in the next step in lines 41 to 44. And in this case, I once again use my ggp simple plot object, and then I use the plus operator to add the scaleXContinuous function. And once again, I'm using the plus operator to add the scale color manual function. So as you can see, you can use the plus operator basically as often as you want to add additional components to your plot. And this makes the ggplot2 package so powerful that it's always basically the same logic, and you can add as many components as you want to your graphics. So in the next example, I want to show you how to use a facet layer. So in the previous examples, we have used scale layers, and now I want to show you how to use different types of layers. And in the next step, I'm once again using our ggp simple plot object. I'm specifying the two scale layers that I have created before. And then on top of this, I'm adding a facet layer. And I do this by specifying the facet wrap function. And within this function, I specify our group color. So after running lines 46 to 50 of the code, you can see at the bottom right that our graphic was split into 3 different subplots. And each of these subplots corresponds to one of the groups in our data frame. On top of this, we may now add a theme layer, and we can do that, as you can see, in lines 52 to 57. So in lines 52 to 56, I'm using basically the same syntax as before. However, then on top of this, I use the theme WB function. The theme WB function contains a very popular theme because it's a very simple theme that, in my opinion, can be used in research papers very well because it shows all the background colors in black and white. So after running lines 52 to 57 of the code, you can see that the plot is updated once again, and the data in our plot is now exactly the same and is shown in exactly the same way as before. However, this time we have used the theme layer to change the background colors of our plot. So until now I have explained how to add further and further layers to a ggplot2 plot. However, it's also possible to use the ggplot2 functions to remove certain components from our plot. And we can do that, as I can show you in the next examples, starting in line 59. So once again, I use our plot object ggp simple. Then I add our scale layers, our facet layer, and our theme layer. However, then I also want to remove a certain component, and for this I add another component to our plot. And usually if you want to remove certain things from your plot, you would use the theme function. And in this case, I want to remove the legend from our plot. So for this reason, I specify the legend.position argument to be equal to none. So if you run lines 59 to 65 of the code, you can see that our plot is updated, and this time the legend was removed. Now the theme function provides many different arguments, as you can see in the next example in lines 67 to 79 of the code. So these lines are exactly the same as in the previous example. However, this time I specify many additional arguments within the theme function. So more precisely, I want to remove all the components on the x-axis, on the y-axis, and I want to set these components to blank, or in other words, I don't want to show these components. So if you run lines 67 to 79 of the code, you can see that all the x and y-axis components have been removed. In case you are interested in a more detailed explanation of the theme function, you may check out the options of the theme function, and there you get a huge list of different ways how to modify your ggplot2 plots. I hope that you understand the basic principles of the ggplot2 package at this point. However, until now we have only used a very simplified data set to visualize our data using ggplot2, and in the next section I want to use a more complex data set to show you how to analyze and visualize more sophisticated data. So in this section we will use a data set that is already provided by the ggplot2 package, and we can load this data set using the data function, as you can see in line 81. And our data set that we are going to load is called diamonds. So after running this line of code, you can see at the top right of RStudio that this new data set is appearing, and we can print the first 6 rows of our data set to the bottom in the RStudio console by running line 82. And then you can see that our data set is a tuple. So the tuple data class is similar to the data frame class, but it's usually used by the tidyverse packages such as ggplot2. And our data set contains information about approximately 54,000 diamonds. And the information that is contained in our data set is stuff like the carat, the cut, the color, the clarity, the depth, and so on about those diamonds. Now, the first takeaway that I want to show you in this section is that even if you are dealing with more complicated data sets as this one, remember this data set has 54,000 rows, the syntax of the ggplot2 package stays basically the same. So remember the very first example in this tutorial where we have created a scatterplot. We can apply basically the same syntax to our more sophisticated data set. So we first start with the ggplot function, then we specify our data set. In this case our data set is called diamonds. Then we specify the aesthetics, and within the aesthetics we specify the column that we want to assign to the x-axis, which in this case will be the price column of our data set, and we specify the column that we want to assign to the y-axis, which is in this case the caret column. And then we add our first layer, which is in this case the geom point layer. So if you run lines 84 to 87 of the code, you can see at the bottom right that our scatterplot was created. As you can see, the design of this scatterplot is basically the same as in the very first example of this tutorial. However, this time we have shown a scatterplot of 54,000 rows. Now, as in the previous section, we can use the different arguments and layer functions of the ggplot2 package to modify our data. So in the next step, I want to add some color to our data set. However, this time I want to specify the color based on the clarity levels of our diamonds. And as you can see, after running lines 89 to 93 of the code, our plot is updated, and this time you can see in the legend on the right side that we have different clarity levels in our data, and you can see that our colors in the plot were changed. And now you could also analyze this plot. So for instance, you can see that the clarity level IF has on average a much lower caret as, for example, the clarity level I1. So now you might say that this plot is still overplotted and that you want to separate each of the clarity groups into a different subplot. And we can do that once again as in our previous example where we used our simple data set by adding a facet layer to our plot. So once again we use the facet wrap function, however this time we use the clarity column as our group indicator. So after running lines 95 to 99 of the code, you can see that a new plot was created, and this time each of the clarity levels is shown in a different subplot. So now you can also see that the correlations between caret and price are different depending on the clarity level. So for instance, it seems like the correlation in the subgroup I1 is higher compared to the subgroup SI2. We can also visualize that by adding another layer to our plot. So in this case, I want to add a linear regression line to each of these subplots. And I can do that by using exactly the same syntax as before, plus the geom smooth function. And since I want to add a linear regression line, I specify the method to be equal to lm. And the formula of our regression model should specify the y variable, which is in this case caret, as the dependent variable, and the x variable, which is in this case price, as the predictor. So after running lines 101 to 107 of the code, you can see at the bottom right of our studio that our plot is updated once again. And as you can see, this time we have added a regression line to each of the subplots. I can also zoom into this plot to show you the results in some more detail. So as you can see, our first impression was confirmed that the group I1 has a higher correlation compared to the other groups, and this is now visualized even better by adding a regression line on top of our subplots. So until now I have explained how to create scatterplots using the ggplot2 package. However, it's very easy to create all different types of plots that are available. And in the next examples, I want to show you how to create different types of plots using the ggplot2 package. And in the very next example, I want to show you how to create a density plot. And for this, we once again specify the ggplot function, so it's very similar compared to the previous examples. Then we specify our data set, then we specify the aesthetics. This time, since we want to show a density plot, we only have to specify one column instead of two. And in this case, I want to visualize the depth of the different diamonds. And then, since we want to draw a density plot, we add the geom density function instead of the geom point function. So after running lines 109 to 111 of the code, you can see at the bottom right that a density plot is shown, which shows a density plot for the entire data set. Now, as in the case of scatter plots, we can also modify this density plot. So for instance, we might change the colors in this plot. In the previous examples where we have shown scatter plots, we have used the col argument to change the color of our points. However, this time I want to change the filling below the density instead of the color of this line. And for this reason, I'm using the fill argument instead of the col argument. And in this case, I want to separate our densities by the different cut levels. And then once again, I add the geom density function. So after running lines 113 to 116 of the code, you can see at the bottom right that multiple overlaid densities have been created. And each of these densities corresponds to one of the cut levels in our data. So you can see that the cut levels correspond to the cut levels fair, good, very good, premium, and ideal. Now you might say, okay, these densities are too overlaid. I cannot see anything in this graph. However, that's no problem because we can modify our plot even further. So for example, we could use the alpha argument within the geom density function, and we can set this argument to be equal to a lower value than 1, which makes our densities transparent. So after running lines 118 to 121 of the code, you can see that our graphic is updated. I can enlarge on this graphic to show the plot a little bit better. And then you can see that our densities now have a certain level of opacity. And for that reason, you can also follow the densities of the different groups. So for instance, you can see that the depth level of the ideal group is much more on the lower depth levels than, for example, the cut fair. So in the previous lines of code, I have shown you how to create ggplot2 density plots. However, another very popular type of plots are so-called bar plots. And I want to show you in the next lines of code how to create such bar plots using the ggplot2 package. And for this, we first need to calculate certain metrics that we want to show in our bar plots. So in this case, I want to show the mean price by clarity levels. And I use the aggregate function to calculate these metrics. So after running lines 123 to 125, a new data set called diamonds MCL is created. And we can print this data set to the bottom in the RStudio console by running line 126 of the code. And then you can see that our new data frame contains only 8 rows and the 2 columns clarity and price. The clarity column contains the different clarity levels, and the price column contains the average price for the diamonds in these clarity groups. Now in the next step, I can use this data set that I have just created within the ggplot function. Within the aesthetics, I specify the clarity and price columns, and then I specify that I want to draw a bar plot. So after running lines 128 to 131 of the code, you can see at the bottom right of RStudio that a new graphic is created, and this graphic shows a bar plot of our average prices by clarity levels. So for instance, in this plot you can see that the clarity level SI2 has a much higher price on average compared to the clarity level VVS1. It's also possible to differentiate the groups in our bar plots even further by drawing a grouped bar plot. And for this, we once again need to create a data set first using the aggregate function. However, this time I specify that I want to calculate the mean price by the subgroups that are created by a combination of the clarity levels and the different colors of our diamonds. So after running lines 133 to 135, another data set called diamonds MCLCO is created, and we can print the first 6 rows of this data set using the head function. And then you can see that we have now 3 columns in our new data set: the clarity levels, the colors of our diamonds, and the average prices for these subgroups. So for instance, the average price of the clarity level I1 and the color D is 3,863. Now, if we want to draw these data in a group bar plot, we would have to specify the ggplot function. Within this function, our new data set. Then we have to specify the aesthetics, so all as we did before. However, this time we use the fill argument, and we set this argument to be equal to our color column, because within the clarity groups we want to create subgroups that correspond to the different colors. Then I add the geom bar layer to this plot, and in this case I specify the position argument to be equal to dodge, and this specifies that we are creating a group bar plot instead of a stacked bar plot. So after running lines 138 to 143, you can see that another bar plot is shown. I can enlarge on this graphic to show it a little bit better. And now you can see that we have created subgroups based on the colors in our data set for each of the clarity levels. And what you can see now is that for most of the clarity levels, the groups or the colors J and I, so the yellow bars and the light green bars, are the most expensive. However, especially for one clarity group, for the clarity group IF, the color D is by far the most expensive group. And this is kind of suspicious, so for that reason you might say I want to analyze this subgroup in some more detail. And this is what I want to show you in the next lines of code. And for this we, for example, could use a box plot. So in lines 145 to 149, I use basically the same starting point. So the specifications within the ggplot function are exactly the same for the previous group bar plot that we have just created and for the box plot that we want to create. However, all I'm changing is that I want to draw a box plot using the geom box plot function instead of a bar plot. So after running lines 145 to 149 of the code, you can see that we have created a grouped box plot where each of the color groups are shown side by side for each clarity level. So the splitting of this plot is exactly the same as in case of the group bar plot that we have created before. However, this time our data is shown in a group box plot instead of a group bar plot. And what you now can see for this specific clarity color combination that was suspicious before, we can see another strange behavior. And this is that the box of this group is very wide. And this indicates that this group has a very large variance. And for that reason, it might make sense to investigate this group even further to see why this large variance occurs. And we can do that by first creating a subset which contains only this subgroup. And we can do that, as you can see, in lines 51 to 52. So in these lines of code, I create a subset of our diamonds data set where only the clarity groups IF and the color group D are contained. So after running these lines of code, a new data set called diamonds D is created, and we can print the first 6 rows of this new data set using the head function. And then you can see that only the colors D and the clarity level F is contained in this new data set. Now we may, for example, to investigate even further on this subgroup, create a density plot for these data. And in this density plot, I want to visualize the price levels for the entire data set that we have just created, so for the data set diamonds D. So after running lines 155 to 157 of the code, a new density plot is shown. And this density plot once again shows a suspicious structure in our data, because now the density is not showing one single peak as you might expect, but it shows two different peaks, which indicates that our density actually contains mixed distributions. So to investigate on this even further, we might print the entire data set with this subset, and we can do that, as you can see, in line 159 using the print function. And then you can see at the bottom in the RStudio console that our entire data set is shown. And as you can see, by having a closer look at these data, the prices heavily increase the further you scroll down in the dataset. And you can also see that the carat levels are increasing at the same time. So it seems like the carat level has a very big impact on the price of this subgroup. And you can also see that especially when the carat level is above 1, the price suddenly increases heavily. So to be honest, I'm not an expert on diamonds, but this seems to be suspicious to me. So for that reason, I would like to show the different distributions where we split our data in two subgroups. One where the carat level is below 1 and another one where the carat level is above 1. And we can do that, as you can see, in the next lines of code. So in these lines of code, I'm using the ggplot function. I specify our diamonds D data set. I want to show the price in a density plot. And in this case, the filling of these densities, and for that reason also the grouping of these densities, should contain one group where the carat level is above 1 and another group where the carat level is not above 1. And then I also specify the alpha argument within the geom_density function to make our densities transparent. So after running lines 161 to 164 of the code, you can see that another density is shown. And as you can see, this plot clearly shows that the carat level of our diamonds in this specific subgroup has a very big impact. And it seems like carat levels below 1 have a much lower price compared to carat levels above 1. You can even see in this plot that there's another suspicious thing going on, because one part of the density of the carat smaller than 1 group has a very high price. So it seems like there are even other indicators for the price than the carat level in this subgroup. However, I think for the sake of this demonstration, we have investigated enough on these data. Of course, if you're interested, you can replicate this code and try to find out why this little third density seems to appear. But for this tutorial, I'm done now. That's all I wanted to explain in this video. In case you want to learn more on this topic, you may check out my homepage, statisticsglobe.com, because on my homepage I have recently published a tutorial in which I'm explaining the content of this video in some more detail. I will put a link to this tutorial into the description of the video, so you can find it there. If you have liked this video or if you have any questions, let me know in the comments section below. I'll try to respond to all comments as soon as I can. Furthermore, make sure to subscribe to my YouTube channel to get notified about future video releases. I have already published about 500 videos on this channel, and I'm releasing new videos on a daily basis. Thanks a lot for watching. See you in the next video.